All right. Good. Good. So feel free to ask questions before we start. Do we have questions regarding what we discussed yesterday? We discussed about why do we need NoSQL and the various key definitions such as CAP theorem, column-oriented databases, and the vertical scaling, horizontal scaling. And then we also discussed about HBase. So HBase is a column family oriented database. All right. All right. So here is the first question from Leela. Prashant, there'll be some recording button somewhere. Are you on Windows? Under the screen sharing tab, there will be a recording button. So the topmost tab on Mac called screen sharing. Do you see? Above dashboard, attendees. Okay, great, great. All right, so the recording has been started by Prasant as well. A question from Leela. Where are these tables created? Whoever creates, they all appear when I say list. That's correct. Okay. Okay. A question from Leela that where are these tables, HBase tables are created? Whoever creates, they all appear when I say list. Can you please give me an example to create one table with one column in row based and one column? Okay, let me understand. So an example to create one table with one column in row based and one column. Actually, I did not get it. Maybe some typing mistake or something. Okay. Let me try to show you what we did yesterday. Okay. So we discussed about this part. All right. So yesterday we talked about the data model, as in we keep on adding columns for one-to-many relationship. Okay. So the way you have an Excel sheet. So uh, let's say I'll show you in Excel sheet. Okay. So that is one thing. And let me first answer your question. So Leela's question is an example on how to create a table with a column. Okay. And let me try to take up the things which we discussed yesterday. So yesterday what we did was we created a table. Okay, we created a table first with a column family. Now in this table, in this column family, we keep on adding more and more and more and more column as and when we need. Just the way we keep adding the rows, we can keep adding the columns. Okay, so the behavior of adding the row and adding the column is exactly identical. All right, that is something very important. Like row has row key, similarly column has a column header. Column header can store some data, row key can store some data. All right, so that's an important thing to understand, that you do while creating a table, you do not have to specify the name of the columns or data type of the columns. Okay, let me take up a specific example what Leela is suggesting. So create a table to create a table C1 which has employee ID in C1 column family and name in C1 column family, and C2 which is an age. Okay, so let's try to create one. All right, so let's say we say create my table, and we say column family, we call it C1 and C2. All right, so this is the definition of creating my table, and let's call it okay, amp 6 fab. Okay, now adding columns is as simple as this, saying put into this table for, let's say, the employee ID. We'll make the employee ID as the row key. Okay, let's just make this employee ID as row key. It's up to you whether you keep one more column for employee ID, which will be a duplicate information. Okay, so we'll just have name in C1 and age in C2. Okay, is that all right? So we could say easily like this: C1 name, and let's say the name is Leela. Okay, and we will say here employee ID is 1. All right. Similarly, we say put employee in this table, the row key, let's say second employee, and uh, let's say it's a second employee, and then we can say, or you can actually remove even the single quote here. Okay, we can remove the single quote and say C2, or let's say C1, sorry, C2 age, and let's say the age is 34. Okay, or age is say, okay. Now you can see that we are creating a table, employee this one, and then putting some data into this. We are saying put into this table with this ID for this column this value. Similarly, same row key, different column family, and 30. If we had to create one more column in C1, let's say employee ID, name, and last name. Okay, last name, and we could have said, okay, we could have said this. All right, now let's try to run it. All right, and how do we run it? We open the console. Okay, here we go. Okay, now let's say hbase shell. All right, so what we can do now is, let's create the table first. Done. Then We add, done, done, and okay. Now if you say list or scan, what is the table name? Okay, so you can see that for row 1, you have all the columns that you wanted. Does it make sense to you? Similarly, you could also open it in Hue, and then in the Hue, you can check inside data browser and see if things are created well. Okay, just give me a second. I'll have to pause the screen for a minute and send it to the team. All right. Okay, so that was quick introduction of HBase and okay, let me copy paste the entire script for all of you, and I'll also write paste the problem statement as well, and in the chat as well. Okay, so Prasanta, did you get it? All right. Now, question two. All right. Let so up to here we are clear, right? And is it Leela? Your first question related where are these HBase table created, right? Is that did that got answer? It is created in this location. Let's have a look at what table we have just created. Okay, just give me a second and then I'll show you. All right, so this one is not working for some reason, and we could just click on this. And here, if we sort it by date, we'll get the table. So under the table, the first thing is the reason ID. Right now, there is only one reason server, one reason this thing. As you keep on increasing the size, more and more reasons will keep on appearing here. So this is auto-generated reason ID. Okay, so first a table is broken into reasons. Right now there is only one reason, and then after reasons there are folders like C1 and C2. See that? And let me try to flush. So I think the flush is okay. So I'm trying to flush so that anything which is in the memory gets cleared and put it to the disk. So you can see that under employee table, there is a reason ID, and under the reason ID, there is a column family. Under the column family is your actual file. So different column family, there will be different files in HDFS. Therefore, the data will be separated. So so if the data is in different regions, then also it's going to be different files. If the data is in different column families, it's going to be in different files. Okay, so always you can visualize that your HBase table starts like this one, and then it starts like this one, where there are maybe if there is C1 here and C2 here, there are two files and single reason. Okay, so table here, And the moment we have more reasons coming in, both of these will get sliced like this. So there'll be four files, two for two for each reason. This is a reason one, this is a reason one, and reason two. So as and when data keeps on increasing, these table will keep on splitting further and further. Okay. Now, as data in both of these increases, further this will split, and then after some time, this. So not like this. So if the data increases in the reason one might also increase, also split horizontally, and then reason two might also split like this. Okay. So it'll keep on splitting further. And so now, after there are four, how many reasons? One, two, three, four. There will be total 8 files. Okay. So these reasons are in reason server. Okay. So you can think of a table being splitted as if it's a big chocolate being splitted, and each piece of the chocolate is being distributed to different machine. So this basically this reason here, this is one reason. Okay. All right, that gets put on one reason server. Basically the reasons can keep on moving between the reason servers. Okay. All right, so basically let me do a quick recap. What happens is, so there is H-based server. H-based server is comprised of H-based master and region servers. Okay. When you create a table in H-base, you are essentially creating a reason. Okay. And basically initially there is one reason dedicated to the whole table. As this table keep on increasing, this reason will split into two, like a fission reaction. And then if each of these individual reasons which are created recently, they will grow at their own path, and if any of them grow beyond a certain size, they will again break, and then these reasons can keep on moving between the reason servers. Okay, so that the load of storing, handling of individual reason is distributed well amongst multiple machines. Okay. And each reason is further splitted into column families, and then uh, e- so one reason is stored in multiple HDFS file, one file for each column family. Okay, so this is how the division is done. Sukhvinder, you did not miss much. I was just recapping what was discussed yesterday. Okay. A question from Leela: do we need to specify the split command? Not really. You don't need to specify. While you create the HBase instance, you configure in the config file. Okay, but if you're installing through Ambari, that too you don't need to configure. It's pre-configured, but you can change it. Right now, each region is configured for 64 MB size. Okay, when the region keeps on growing beyond 64 MB, it will break into two regions. Okay, so you can think of like this way, that there is a big, so you consider the whole table as made up of many rows. Okay, and each row is sorry, so you imagine your table to be made up of many rows. Okay, each row, now let's take an analogy of your table with a Oxford dictionary. Okay, so let's say you're storing, in a classic sense, you are storing key and value the way Oxford Dictionary has key, word, and meanings. Okay? And the data is ordered in exactly the way it is ordered in Oxford Dictionary. It's ordered by the key. In Oxford Dictionary, the word the dictionary is sorted by the word. Okay? So so you can always think of your table as if it's a big Oxford dictionary in the HBase where there is a key and there is a value, and each page to be a reason. Okay, each page to be a reason. Just that Oxford dictionary has been created and is static, your table is increasing. So each page of the dictionary has got certain ranges, like from every page at the top says that this page includes words from here to there. In the similar fashion, every reason is defined by starting row key and the ending row key. All right, and these reasons or these reasons which are created out of the rows are divided are distributed to the reason servers. Okay, so if you have only three reason servers and you have 300 reasons, okay, so each reason server might get 100 reason each. Similarly, if you have, let's say you are trying to have a team of 15 people act like a dictionary, so and you want to build this really quick response system so that if somebody asks a word you can answer it, give the meaning quickly. So what you do is you take three, let's say you take three people, you put them on the stage and give them one third dictionary, and you ask them, whenever somebody asks you a word, you route that query to these three people. That way you know clearly that from which word to which word is which with which person, and which word to which word is with the second one, and so on. Okay, so that's how it keeps on going. Let me just show you the diagram that will make you very clear. Okay, so you can think of, there are these three attendees, three people who you have nominated and given them various sections of the dictionary, and you are keeping track which section is with which person. Okay, so you are HBase master, and individual person is reason server, and the papers which you have given to individual is the reasons. Okay, so basically that's exactly the purpose of HBase. All right. Okay, so what happens is that initially the whole table will be only having single reason. As in when you are adding more data to it, what will happen is this region is growing, and the moment it grows beyond a certain size, it is split exactly into two halves, and two regions are created. Okay, this is splitting of the regions. All right, now a question from Suraj: how did we assign the name empid to the column here? So the quick answer is we did not. Okay, so we did not. We basically made that row key as one, and the column called row key does not have any header. Yeah. Okay, question from Vivek. The reasons are exclusive of last row key? Yes. Meaning it would say that the reason starts from A and goes up to B, while B will not be on this reason, but B will be the starting point of the next reason. Now, question from Suraj is, how do we access a particular row? Okay, so to access a particular row, let's say here, we could always say get emp6 fab and specify 1. Do you see that? For the row number 1, we have accessed the data. Okay, a question from Vivek. Where does the lastmost key goes? Lastmost key is generally symbolic. They create a very good question, by the way, Vivek. So the question is, when we are saying my first reason is starting at A, let's say, let's say, uh, abscond, and then going up to cow and going up to monkey. Second reason, okay, which is starting at, say, let's say this one is going up to monkey, and this one will be starting at monkey. So generally the way it's kept is this way, meaning first reason contains just before up to monkey, just before up to monkey. Okay, so what will the second reason which goes up to the last element? So generally we create some kind of the last key notation. Okay, it internally has some kind of a last key notation. Okay, is internally has a last key notation. So the second reason is by default from this till the last key. Okay, it internally has that annotation called last key. It's like infinity in case of a number line. All right. So that was a quick recap of what we discussed yesterday. All right. Sneha, do you need more description of what we discussed yesterday? Okay. Okay. So in simple words, HBase provides you a great ability to distribute table in multiple machines. Each machines runs something called region servers, and there is one master called HBase master, just exactly the way name node and data nodes are. Okay, so the HBase master just keeps the index, while the region servers keep the actual sections of the data. Okay. Yes. So the monkey is being repeated because first section of the table, when they describe that, hey, I'm starting at this, ending at this, it means I'm ending at just before monkey. It first reason would not include monkey. Okay. Similarly, here there'll be some infinity kind of last key that will be there, which is not included anyway. A question from Asmeet is, what is the difference between SQL and NoSQL? NoSQLs are essentially for storing humongous data. All right. And are distributed in nature. In a SQL, there is only one server who takes all the heat, and there is just one backup. Here, in case of NoSQLs, generally the data is distributed on many machines. Okay, so I think you could go through the yesterday's session that will describe you and give you more idea about the NoSQL, cap theorem, and all that. If afterwards, if you have a question, just let me know. All right. Okay. So Leela's question is, what's the difference between HBase and NoSQL? HBase is a NoSQL database. All right. HBase is a NoSQL database. Basically, all these new databases which are trying to provide a huge ability to churn data and store data and modify data, they are not able to provide you the qualities of SQL. Therefore, most of these databases are called NoSQL databases, or they are not, most of them are not even being qualified enough to be called a database. Most of them are called data stores. Okay, so that was our recap of yesterday. We talked about data model, how to store and how to build one to many relationship, and the primary index you need to control in order to scan the data. Primary as in row key should be such that whatever data you need to scan through, the data should be ordered in a way that they ordered in a way such that the things you need to gather are stored in the nearby rows. Okay, so accordingly you will have to tweak your row key. All right, so we went through all of this. Okay, we were talking about MapReducer. So the in the similar fashion when we discussed in initial sessions, whereby we were churning, the way we were churning the HDFS file through MapReduce, in the similar fashion you can churn HBase tables via MapReduce. Okay, in case of flat files, in case of HDFS file, what was happening is the definition of a record was being controlled by input data format, right? Here by default, so in the case of our usual MapReduce, the row definition was governed by what is our input format. If our input format is text input format, then individual record that comes in is a line from your text file. Okay, in our case, here in HBase, by default, the input record is an individual row. It is an individual row from HBase table, and you write the map and you give out the key value in exactly the same fashion. Similarly, you create a reducer. Reducer will get the key and the array of values, and then it can write the output to the context exactly in the same fashion we did the map reduce in our usual scenarios. So, and once you're done with creating the mapper and reducer, you can create a config object, and then you can launch the job by saying job dot wait for completion. So you specify the mapping part, you specify the reducer part, and then you specify number of reducer, and then you wait for completion. Okay, there is no fixed order, as in you can specify this before table mapper, as long as the job object has been created before you operate upon job object. So first you create the job object out of the config, and then you specify all the parameters in the job. Okay, you create a new scan. New scan means what area of the table you want to scan. Okay, generally you can specify that you start at this row key and at this row key and so on, but here we are not specifying that. Okay, that's it. All right, so the next thing I would like to discuss is the bloom filter. Okay, the bloom filter. Okay, a question from Asok is where we need to write the code. We can basically execute in the same fashion, saying Hadoop and jar and the bundled code. Okay, it'll work in the same fashion. All right. Now there are few things I want to discuss. One of them is bloom filter. Although you would not require anything to do with bloom filter, but since bloom filter as a concept is asked by many people in the interviews, I would like to describe what is a bloom filter. Okay, it's an important concept to know. Okay, so there was a so it's basically, let's start with a small tale. So there was a person who was very, very busy. Let's call him A. He was very busy. Okay? Why? Too many people coming to him asking if their name, asking. So A is a watchman, okay, who is very busy because too many people are coming to him and asking if his name is in the register. Okay? So A is extremely busy in looking up the name of the person who are coming to A. Okay, so I mean, millions of people are coming every day just to get their name checked. Okay, and this register here is huge. Okay, register here is has billions of entries. Okay, billions of entries. So every time this watchman gets saying that, hey, can you check my name in the register? He takes some 5 minutes to check in the register. Okay. And what he found that most of these people who come to him do not have the name in the register. Okay. So what he did was he suggested a plan to hire another watchman. Okay, called first point of contact or bloom filter. So B is that watchman who is recently hired, okay, and what he was given is, say, four letter word, four letters of each word in the big register. Okay, for only four letters of each word in the big register. That's it. Okay, so hardly how many entries? Anybody? So how many total four letter words are possible? 26 into 26 into 26. So only these many entries. All right. So what was done was, out of billions of entries in that big register, only first four letters were picked up and new register was created and given to the watchman, newly hired watchman. Now, this watchman's duty is to first, everybody comes to him first. In case their first four letters are matching, only then the request, only then the checking is done by the main watchman in the register. Now, what you see here is, since so the load of searching has been shared by the two watchmen. In case in case somebody's first four letters are matching, you can see that there is a duplicacy of effort. First B is searching and then A is searching, right? So similarly, this four letter of each word is a scheme. Okay, it's a scheme. It could be hash code, okay, or you can say that pick up the alternate letters from the word and then pick up the alternate four letters, or you might say that just find the numeric value of every letter, sum it up and prepare a number. So basically a scheme which generates some kind of a code given to the second watchman, so that this newly hired watchman, who is the entry point, first entry point, gets a small register. Okay, he gets a very small register so that he can do the initial checking really fast. Okay, and when it's a time to do the thorough checking, then the main register is searched. Okay, so basically the what you see here is, when the data keeps on growing bigger and bigger, even the binary search as in, if you guys have used traditional registers, where the uh, in the library they keep a lot of cards stacked in big almirahs in alphabetic order. So there you keep on very quickly jumping to a particular letter and then keep on going further and further. So when even searching in a sorted list is also taking a lot of time, okay, then a scheme like a bloom filter is very much required. Okay, so this is a very important idea in the concept of any searching ways. So this watchman or the bloom filter which has been hired freshly, B, okay, is basically, when he says yes, okay, only then a watchman works in looking up his name. If he says no, then a watchman is not bothered at all. So B watchman, who is the first entry point, can give false positive, okay, which is validated by A. False positive as in, he says yes, but it's not always the case. Okay. All right. So Vivek's question is it okay to change this color? Actually, I'm colorblind, so I prefer too bright colors, and that's the reason. Otherwise, things are not greatly visible to me. All right. So never mind. And moreover, it's an image, so you can see. Now, I want to show you this diagram. This will be more clear. So this is that B watchman. This is the A watchman. So first user comes in and says, hey, do you have key 1? This filter or the B watchman says no. Then storage is not consulted at all. Okay? Because uh, if the code did not match, so it's 100% sure that he does not exist in the actual storage. Okay? Now, if another user comes in and says, hey, do you have key 2? And this Bloom filter says, yes, I do. Okay, then the actual storage is consulted. Now the actual storage might say yes or might say no. All right, so this is a Bloom filter. Does it make sense to you now? So bloom filter as an idea, is it clear to you? It's nothing but hiring a personal assistant who can do the first form of checking. So Leela says B will be too busy than A. Yes, the total number of requests coming to B will be really, really high. But good news is since B only has to look through these small entries, which can be maintained in the RAM, his response time of B will be really high. Now, very good question from Parvez. How the integrity between filter and storage is maintained? Thank you, Prasad. Thank you, Prasant, for giving the answer. All right. Now, a question from Parvez is a very good one. So, how the integrity between filter and storage is maintained? Okay. Every time a record is added into the table, both actual storage and the Bloom filter is updated. Please note that Bloom filter may not be updated if the key is already existing in the Bloom filter. All right, because code is already existing, because every row, Sneha's question is it's working like index sort of a data structure? Yes, it's a kind of index, but in index the thing is that if index is not found, it's not found. Okay, in index, if there is a table on which we have created index, if we search inside index, if it's not found, it's not found. Okay. Yes. So every time an entry is made into storage, the Bloom filter is updated. Okay. Yes, Parvez, you can say that it's a hybrid of index and log. Is it possible that B says no, but it exists in A? No. If this happens, then the whole Bloom filter will crashes. Okay? That means your Bloom filter is not correctly updated. Yes, Sneha? Asmit is saying if record exceed then 17 something, then it will make 5 alphabet key. No, it'll still have 4 alphabet key. Say ABHI. So in actual storage, okay, might have Abhinav, Abhishek, and Abhimanyu. Okay, in in the filter, okay, filter called B, this is actual storage is A, and the Bloom filter. Okay. Now you get the I mean you can always keep in mind A means actual storage and B means Bloom filter. Now Bloom filter will still have Abhi only one. So when somebody says, "Hey, I am," so if user says, "I am Abhiraj," okay, B will say yes, and then A will say no. All right. If the user says, "I am," say Ashish, B will say no and no further questions. In case a person says, "I am Abhinav," then B will say yes and A will say yes. Okay? Okay. So another question from yeah, very all right. Makes sense to you? So even if you keep on increasing actual storage, Bloom filter size will remain the same. Okay? Because it won't become very big. Is it clear to Vivek? Sneha, does that answer your question? I think it answers your question. All right? Good, good. Now, okay. So Vivek's question is, what if person's name is less than the key length? So key length is okay, whatever you choose. Okay. So the strategy, right now I've taken a very simple case of converting a name into a code. The Bloom filter could have been something like this. Okay. The name represented by a number. Okay. So I'll show you something. A Bloom filter could be something like, if you have Sandeep here, the Bloom filter could be MD5 sum. Okay. You can see no matter what is the input, this MD5 sum, which is converting this string into hash code, will have the same size. Even if I have, say, very huge file. Okay, let's say I have this gypsum file which is 2.7 MB. MD5 sum will always create the same string. Okay, so there could be many strategies to create this code which is given to B. Okay, there are many strategies, and uh, I just took the most simple one, which is more easier to explain to everyone. Okay, here three letter name is also okay with Abhi. All right. Yes. Good, good. Now there is one question which I am yet to answer. How is the Bloom filter key decided? Why four letter? Why not three or five? It is just an example. In reality, the the key is decided by hash code, or in Java hash code. You must have seen that every string is converted into a number. Okay, the way we convert A to 1, B to C, B to 2, C to 3, and so on. Similarly, you can have a scheme to convert a big string into a number. All right. Now, how is it relevant? How is it relevant in case of HBase? Okay. How is it relevant? So, Bloom filter by default are defined by default in HBase. Okay, and they are enabled per column family. So you can use h column descriptor and say set Bloom filter type to none, row, and row column. Okay, so by default they are enabled, and I think it's a row column. So on what basis the key of the Bloom filter gets generated? By default, it's based on all the values of row and column names, row key and column keys, and column family name. You can change it to consider only the row key, okay? Uh, and you can say none, which means there'll be no Bloom filter, and effectively your search will be little slower. Okay, so the Bloom filter is comes from a lot of actually statistically it's a statistically based data structure, and it comes after probably the name of a researcher. Okay, that's why it's called Bloom filter. Okay, because it's filtering lot of load which is reaching the main storage. That's why it's called Bloom. Right, Parvez? All right. Okay, so you can take a look at more details at that place. All right. Now, sometimes you might want to process. Okay, idea is important than the code. So sometimes you want to do pre-processing or post-processing of the data that has come in. Okay, pre-processing as in you want to impose the security on a H-based table. Okay, so as the request come in, you want to check whether it's coming from the right user or not. If not, make it read only, give the error. And so we can create co-processors. The way every database has something called triggers that get triggered before I mean at various point of time. In the similar way, you have co-processors which get triggered at various point of time. Okay, so you they get triggered either before and after, pre or post, and it can be pre-put, pre-get, and pre-delete. Okay, pre-put, pre-get, and pre-delete. Similarly, they can be executed post-put, post get, and post delete. So all you need to do is create your class which should extend the base region observer, and then you override the corresponding method. You don't need to override all of them. Whatever you want to alter the behavior, you can override that particular one. Let's say you want to put a security restriction that only few people should be allowed to read from this table. Okay, or you want to put a restriction like if somebody has come in to read a particular data, and if they are not if they are not from the admin group, you don't want to allow them. So that's pre-get. Or uh, there could be many cases for the pre-get. Okay, so you provide a coprocessor environment and a get, and then if access is not allowed, then you throw an error and so on. Okay, let's say before the data gets put into the database, you want to throw an error if the data is not in a valid format, so you can override a method called preput. Similarly, if you don't want to allow user deleting the data, you can override pre-delete. Similarly, you can also do post processing by overriding post get and all. Now, once you have created this class, after compiling, what do you do with this? One, the step is you copy it into the region server lib folder, and then you add it there hbase site.xml and mention its name in the in this property called coprocessor region classes. Here you add the name of your class as well. Okay, now but that would require you to restart the hbase master. Okay, okay, a better thing would be, Uh, Better thing would be that you, okay, better thing would be that you put this into the table itself. You put the jar in, mention the jar into the table itself by using a path class, and put the jar in the HDFS and mention that path here. And then you basically create a cell, create the cell in the table with the name as coprocessor $1 and the value as the actual full class name. Okay, so that way you will be able to put it in the table itself, and you don't have to restart the database, and it will load the logic from there. All right, you can make a call to HBase table using the REST interface. A question from Suraj: where is the Bloom filter located? Is it with HBase master or region server? Okay, it is generally with HBase master. So it's basically with HBase master, and that's how it works. Good question, Suraj. A question from Sneha, a very good one. So where do we use a coprocessor? One, for security checks. Second, the input validation. Okay, and or you can say author authorization check. Okay, similarly, data presentation logic sometime, and so on. All right. Okay, so that's it. And a question from Prabhu is: are Bloom filters coprocessors used mainly in writing MapReduce job on HBase data? No. So Bloom filter used to reduce the load on HBase when there are many lookups happening. Coprocessors are used to restrict different users from accessing the table, and MapReduce jobs are written in order to process data in the humongous table. When we think of HBase table, it's generally having billions of records. Okay, let's say you are computing the page rank based on this, or let's say you are doing the sentiment analysis based on the data stored in HBase. You would like to write that logic of sentiment analysis, computing the references, sentiments, and all of that in a MapReduce job. Okay. Okay, Anian is saying key for Bloom filter can be changed only through jar file, or there are any other tools in Hive. So you can change the key for Bloom filter using a config file. I mean, you can change the config and that's it. All right. You can see the config in the Ambari, and there you can make the change. All right. Question from Sneha. Does it provide digital signature? Okay. Do you mean HTTPS? A question from Parvez: can we use instruction in HBase? Yes. So basically, the way, while we talked about big storage, there's something called HBase storage. So you could say load my data set from this particular table using HBase storage. Okay, so pig will load data from HBase and run the MapReduce over the HBase. All right. So yes, you can put the digital signature, or the better things are like you can hide HBase server behind Apache or Nginx. Okay, and put the put the digital signature, or we call it like SSH key, not SSH key, we call them HTTPS key on Apache or Nginx. Okay, that's the right approach to do. Okay, hide so the way we are doing right now, if you see here, when you like here, like this console is here, right? e.cloudxlab.com. It's basically Nginx. First request goes to Nginx, then it redirects the request to the web console. Okay, so most of the services are hidden behind Nginx. Okay, Prabhu's question is, can't we say any code we write in Java to process data is a MapReduce job? Not really. Again, so I'll explain to you why. So MapReduce is just one form of logic. Okay, there are some logic, for example, creating UDF. Second, let's say creating big UDF. Okay, creating a Hive UDF, or creating a program to read from HDFS or HBase directly. Okay, they don't use MapReduce. Did I understand your question correctly? All right. Um, so Leela's question is, how can we save these sessions to refer them later? Which sessions? The sessions which we are running currently. So I'm providing these notes as well as I'm recording these sessions, so you can have a look at the recordings later. Did I understand your question correctly? All right, great set of questions. Okay, moving on. So you can access HBase from the web URL as well, so that you can, if even if the HBase server is hosted on our premises at CloudX Lab, you can use the same thing inside your JavaScript code. Okay, so you can basically invoke kind of, you can basically pull the data from HBase into your project using a REST call. REST call here is the grammar. Grammar means it says that the initial one is table. You can specify after that either the table name. Afterward, optionally, you can mention the row name. Sorry, you have to mention table name and the row name. Okay, you have to mention the table name slash row name slash. This rest is optional. Okay, this is optional. You, so basically that's a little complex way to describe things, but it's quite obvious, so you can see that. Okay, let me see what happens. Okay, let me see if it's running on D. Doesn't look like. Anyway, let me first start my REST server. How do you start a REST server? You can go here and say, in you can give a different port, by the way. You can give a different port in the console, and your own personal REST server has been started. Okay, so my personal server has been started here. Similarly, now I can go here and say e, okay, which is the machine e.cloudxlab.com. Okay, so e.cloudxlab, and so it says, all right, looks like it has been blocked. It says Jetty's outbound port is 8085. Is it so? Why? e.cloudxlab. No, it doesn't. So our Nginx is not allowing this particular connection. So let me first check. Okay, let me just. All right, let me make a note of it. All right. All right. So never mind. So it's okay. So we'll have to check, but the process is same. First, you start the server on a particular port, REST server, and then you can make a call to whatever data you want to call. Okay. So right, you can say here it will be e.cloudxlab, then the port number, the table name, the row ID, column ID, and so on. Okay. So this way you can access HBase via the browser. In case you want to access HBase via JDBC connector, which means from your usual Java code, you can use JDBC. Okay, you can use a project called Apache Phoenix, which is quite good when it comes to the accessing it in a relational. It kind of pretends that it's a relational database, or it kind of make it look like the traditional database. Okay, so that's pretty much with respect to the HBase. All right, so let's start with our next discussion. Good. Now there's something very important I would like to cover today. It's called Zookeeper. Okay, great, great. So we all talk about Hadoop, HBase, HDFS, and everything, but Zookeeper is actually one of those tools which are very, very important. It's quite independent in the sense that the way everybody starting from Pig, Hive, HBase is depending on HDFS. HDFS depends only on Zookeeper. You will see how. Okay, you will see how. Ashok's question is, can we do all the operation like get, put, post? Yes, we can do all the operations. Okay, all right. Now coming back to now, before I start, I want to pose. I want to pose a question to all of you. Okay? Yes. I want to pose a question to all of you. So there was this assignment which people get. One more thing, there is an assignment for HBase, and I would like to go through that assignment before it gets too late. Okay. So the assignment I would like to describe, that sometimes something I always miss. So the assignment is this. It's a subjective assignment. Okay. So yesterday we discussed how to store the the data which was crawled with the relationship, like which page is pointing to which page, and so on. Okay, so we emulated one to many relationship in the HBase yesterday in one of the discussion. Today, the assignment for you is, let's say you have to design a simple Gmail like email storage. A email storage which is similar to Gmail, you have to emulate. The only requirement is that it should be able to handle many users, okay? And it should be able to handle huge data. It should be able to handle many users, and it should be able to handle huge data. And whenever a user comes in, it should be able to give all his emails easily. So you have to design the HBase database such that it's it can handle humongous load, as in it can handle petabytes of data. Okay, so so the questions that you need to answer is, what will be the tables in each of these tables, what will be the row keys, and what will be the column families, what will be the columns under each column family for each of the table. Now it's up to you to imagine what all email system you want to provide, but from my side all I want is the normal simple email. I don't want any labeling. I don't want all of this archive, this and that. All I want is that when the user comes in, they should be able to query, they should be able to get their email details. Okay. So, so that is the assignment for today. All right. Now, the next question which I want to ask you is, you are writing something called email processor. It could be something like which is creating an email index of the email. Okay, and you are not supposed to modify email. Okay, so the server which contains the emails of the user is single. There is a single machine containing the emails of all the users, and the processors run on multiple machines. So there are multiple machines running the processor who can read the data from, who can read emails from this inbox. And the only problem is that the email processors cannot modify the inbox. Okay, inbox is read only for them. Okay, the other insight is that each email has got a unique identifier. Now, question to you is, how would you make sure that no two email processors process the same email? Okay, if one email processor is working on an email, don't process it again. How would you ensure that? Anyone, quickly? Yes. So there are multiple email processors who are talking to inbox, reading the emails and trying to index it or do whatever processing they want. Yes, anyone? Leela is saying we can put locking. Okay, as I told you that you cannot modify this inbox. You cannot even put a lock. Okay, so these email processors have exactly same logic. Email processors have exactly same logic. Whatever logic you write in one email processor, that's going to be replicated parallelly on all of this. All of these email processors are going to read from the same inbox, process the same emails parallelly and continuously. Okay, now you have to avoid that one email processor does not read, and if the same email is being processed by some other email processor. Yes. Sneha says user index. Yes, please go into the details. Okay, good, good. So some of you have actually answered in terms of Bloom filter. Yes, actually, I'm really happy that you guys have got the idea of Bloom filter. So yes, in most of the cases, Bloom filter is used, but you have to have a separate machine which will have the Bloom filter. Good, good. So yes. Please note that when you are running in multiple threads, but on the same machine, or you can say inside a same process, multiple threads can create locks such that one thread does not step on other threads' feet. Okay, so that one thread does not access the same data, so that multiple threads can coordinate. But if there are multiple processes, threads are totally useless. Okay, threads of one process can access the data locked by threads in another process. Okay, so in those cases what we used to do is we used to create a local file to coordinate, but here these email processors are separate machines. So what we need to do is we need to create a central database so that we can write we can write the data in that database and coordinate. And in that database you could actually have something like a bloom filter. Bloom filter is actually quite a great concept for the situations like these. Okay, so for situations like these, bloom filters are, I had never thought of it, but now since you guys have answered, I'm realizing that your answer is quite good. So the idea which I wanted to put forward is you need an external service for the coordination between email processors. And when we have been talking about distributed computing, the idea is mainly around this coordination. The idea is mainly around coordination amongst distributed machines. So whether we has so many region servers and HBase is trying to talk to them, or these region servers are coordinating amongst each other. Similarly, data nodes are coordinating amongst themselves. Then primary name node, secondary name node have to coordinate between themselves, and there are many more services that require coordination. Okay, that require coordination. Similarly, for our say CloudX lab right now, we are building our own way so that our users can coordinate well with each other. So basically, whenever there are multiple servers running parallelly in the network and then they need to coordinate amongst themselves, it's very difficult to use the it's very difficult to use the threads or process based locks because these are different machines. Okay, so the general idea used to be let's create a central database, but again this central database could become the bottleneck because if you have 1,000 processes running parallelly in the cluster, and these 1,000 processes require a coordination, a really fast paced environment, this this coordinator, this central database to which all these email processors are talking, all these processes, multi thousands of processes are talking, could become the bottleneck easily. And that's where comes Zookeeper. Zookeeper is a distributed coordination service for distributed applications. It exposes a very simple set of construct or primitives such as like get and put. Just like a file system, you have a folder structure, you create a folder there so that nobody else can create that folder in that. So similarly, Zookeeper also comes with this nice tree structure so that many processes can create this nodes, trees inside this tree, so that all the processes can happily coordinate with each other. Okay, and it is itself, Zookeeper itself is a distributed, meaning this locking system which looks like a robust single machine, but inside it runs on many machines. We will talk about it today because this is probably the very important idea. Okay, so it is used for synchronization, configuration maintenance, and coordination service that does not suffer from race condition or deadlock. Okay, because every system, if since we are talking about big data need to be handled by many machines, and all these many machines need to coordinate with each other at some point or another. In those cases, Zookeeper will be your go-to guy. Okay, so all right. So your answers have been pretty great. Okay. Brilliant answers. Anian, Parvez, Mohammad, Suraj, Leela, and Vijay, and Prabhu, Thiru, Sukhvinder. Brilliant set of answers. All right. All right. Good. So basically, this is what we're going to talk about, the structure of Zookeeper. Now, why are we talking about Zookeeper in detail? Because the structure of Zookeeper is important because it's going to teach us something very important. So far so far we have been having a situation where we were nominating who is master and who is slave. We, being the administrator, we were nominating, okay, this guy is h base master and rest are the data node. Similarly, this one is a name node, others are data node, and so on. In case of Zookeeper, this is done through election. Just like in a democracy, the master and slave is decided based on elections. And that's why Zookeeper is kind of truly distributed service. Okay, so we will go into the details of Zookeeper today. So uh, Zookeeper's architecture is something which is used by MongoDB and some more. Okay, we will go into the details, and it's very important to learn this aspect. A question from Prabhu is there a prioritization of jobs in Zookeeper? There is no such thing as It does not execute the jobs. It basically provides kind of a file system in which the jobs can write their data and read their data from. Okay. So the coordination prioritization is done by Uzi. Okay. Good. So let's take a break for 10 minutes and come back. All right, so should we start now? Great. All right. To in, installing Zookeeper, you can extract it and start it, but you don't need to worry about installing on in the case of CloudX Lab. And also, it comes pre-installed with Ambari if you are using Ambari for installation. Okay, so I've just run my. Okay, so right now, what does it say? Zline support is up, and okay, all right. So once you log in into the console here, you type the command called zookeeper dash client, and that way you will be able to see the zookeeper. Okay, that's how we're going to start. Let me just explain to you what does it mean by zookeeper. So let's go with the practical first and then theory later. Okay, so the data model is more like a tree structure. Okay, more like a tree structure. um, it contains basically the nodes one inside another. The top level is slash contains one node called Jew here, and inside Jew you have duck, goat, and cow. Okay, so each node is called Z node, as in Z node, and Z node can have children can have data. Okay, every Gnode can have children, every Gnode can have data. Gnode form a hierarchical space. Also, these kind of names are illegal, like this, are illegal. And on every node contains the name of the node as well as data. So every node knows whose parent, who is its parent, as well as what is its name and what kind of data it is storing. What data is it storing? So when you change the data on a node, okay, you cannot say append. You can only overwrite the data or change the data. Okay, so that's in very simple words. That's our data model. Okay, so let's, before jumping into it, going into theory, let me try to show you. Okay, so we are into Zookeeper client. Right now, let's have a look at the way you see the tree structure is just like Unix. You say ls slash, you can see all the subnodes of slash. So right now there are so many nodes. And why there are so many nodes? Because the whole system is actually using Zookeeper. Okay, in every folder, different system is keeping its data. For example, here we have Prezi, we have brokers. Brokers is Kafka brokers. Storm is also keeping its data, and HBase is also keeping its data under HBase unsecure. You can see that you have under HBase, you have all of this information inside Zookeeper. What table locks are enabled? What are the region servers? So you can see inside Zookeeper, everybody keeps its data. Okay, data is in configuration. Right now under region server, there are only these two region servers active right now. There are only two region servers running. And as and when more region servers will run, they will make their entry here. Okay, so you can see ls slash, it shows all the Z nodes which are children of slash. Okay, and you can go further into each one like this. Okay, at every node you can say get. It'll show you the data. Right now its data is blank. Okay, and let me go till the last point. Zookeeper quota. Okay, let me say get. You can see again its data is blank, so it's okay to have a blank data. All right, let me go into something meaningful. Let's say I say get slash 12 December. I'm saying give me the data of 12 December. So it says its data is initial. All right. I'll talk about all of the details. So I hope you are comfortable with this. So you can see under config is I think it's a Kafka config. It has topics inside it. You can see there are topics inside it, and let's see get. Okay, so there is no information inside it, and let's say I want to check what is the topic containing. Topic is containing this kind of a JSON data. Okay, it says version number this, config this. Okay, so every node has got a name, it has got a children. Okay, like for example, these are the various nodes which contain has their names and has got some children, uh, and every node would also optionally would have children. For example, Storm has these many children, and under credentials they'll have more details and so on. If you want to see the data, what is there inside here? Okay, you can see get. All right, so is it clear to everyone? I hope it's not that big a deal. Okay, Ashok's question is each node knows their parent. Do they know siblings? No. Okay, but every node knows their children. Actually, I'm not sure if every node knows their parent, but every parent knows its children. It's a typical tree structure. There is no linking. Good. So this way, that is this data model. I hope this data model is clear to you. Now let's go one step further. Let's go one step further. Now there are different kind of nodes. By default, every node is persistent. You make a change to it, it is persisted and kept. Okay? And it remains there until you explicitly delete it. Okay, so the way you create a node is in a very simple way. You can say create slash is the parent, and let's say we want to create a z node called 6 fab. Okay, we want to create 6 fab and we want to put our secret data inside it. Okay, so we have created this node called 6 fab. It's created here. We are using create command, and then um, here you can see if you want to see the data of 6 fab, we can say get this. Okay, here it's basically expecting us to give the JSON data. Okay, I think it wants us to. Okay, you can see that it has created the data that way, and all right. All right, so we have been able to change the data, get the data, create a node, and we can also create another node inside 6fab saying Sandeep. Okay, and okay, we can put some information to Sandeep saying he's an instructor. Okay, so we can say okay. So now you can see that we have been able to create this node. Okay, so we have been able to create a node, ls a node, and then update a node and get the data of the node. Sukhvinder's question is, so Zookeeper is to store configuration. Kind of, yes. There are multiple use cases you can think of Zookeeper. Okay. We'll also talk about in what circumstances we should not be using Zookeeper. All right. So the nodes which we created just now were the nodes that we created just now were basically persistent node. Okay, we can delete these nodes by saying delete 6 fab and something. Okay, okay, so you can see now the data has been deleted. If you are also logged in into a Zookeeper client, you'll be able to see what am I seeing right now. Okay, so this way you can create, delete, check the details, check the children and so on of a particular node inside Zookeeper. All right. Now there are some very interesting kind of nodes. You can create an ephemeral node which will be deleted by Zookeeper as soon as the session ends. I'm connected right now. If I create a ephemeral node, it will basically disappear as soon as I get disconnected. Okay, so it cannot have children. Let me just show you first. Okay, so let me create an ephemeral node by saying create minus e 6 fab. Okay, and the node title is Sandeep is online. Okay, sorry, this somehow hates. Okay, so I'll say some data here. Okay, so I've created this Zookeeper node. Okay, right now you can also see there is one node called Sandeep is online. If I exit, so the session has been ended. Okay, that particular session which created that node, okay, has ended. Therefore, that node will disappear after some time. Okay, that node will disappear because that session has been ended. Okay, so these are ephemeral nodes. Ephemeral node exists as long as your session is active. It cannot have children, not even the ephemeral ones, though it's tied to the client session, but it is visible to everyone. You can create your ephemeral node like this. Okay, so that is, now let's check. It has been deleted. Let me log in again and check 6 fab. All right, it has disappeared after some time. Okay, so this is like creating an attendance system. So every node needs to keep on sending pings to the server so that the server keeps their sessions active, and therefore it will show their presence. Prabhu's question is, what is the use case to create custom node in Zookeeper? Because Zookeeper is a data store, why do we need to create folders in a file system or a file in the file system to store some kind of a centralized data? Satyan's question is, even if you have not closed the session, the ephemeral node is deleted. No. Ephemeral node got deleted because I exited and the session got terminated. That's why the ephemeral node got deleted. If I'm logged in on the shell, it will never get deleted. Okay? Okay, so basically a sequential, another kind of node is called sequential node. What is a sequential node? In case of sequential node, Zookeeper creates a sequence number. Okay, the sequence number starts from 0 for every parent. Okay, for every parent, the sequence number starts from 0. So, and this whatever when you're creating a sequential node, you just provide the prefix. The sequence number is appended by Zookeeper to the prefix. Okay, for example, I will show you right now how many nodes have been so far created in 6fab. We have created around 3 nodes inside 6fab. Okay, one earlier which we deleted, then we created an ephemeral node. So I think we have created two sub nodes inside 6fab. That means if I create a sequential node inside 6fab, i will get I will get, okay, let me just provide this my prefix. I'm just writing my prefix inside 6fab, and and some data inside it. So it'll automatically create this node. You see, the name of the node is mypref0002. So it started with 0. For 0, it gave to the first node which we created called Sandeep. And then second node 1 was the one which disappeared. And third one is the one, the sequential node. So the sequential running number keeps on going for every node. It's just that it's utilized in while creating a sequential node. So every parent keeps a count of their children by the way of this sequence number. Okay, so based on this, you can always figure out how many children, how many children have been created for a particular node. Okay, so you can see that, and let me also check if we can say get 6fab. Okay, all right. So this way you can keep a count of what's going on, and so this counter keeps on monotonically increasing. If I create another node here, it will increase by 1. Okay, you can see that it has increased by 1. I can, even if I change the prefix, the counter will be in the same way. You can see if I provide empty, then the node of the the name of the z node will be only the number. Okay, so this is another kind of z node called sequential node. All right. Now the architecture. This is very important. I hope everybody is up and running with Zookeeper. Yes. Prashant's question is, can we see these Zookeeper node on Hue? Yes, you can. Okay, you can see the Zookeeper here. All right, it's showing the current status that. All right, also what I was about to show you, that also you can see. Okay, right now you can see how many machines are there. One, two, three, four, 5. After colon it's the port number, which is 2181, and before colon is the IP address. So you can see that here there are 5 machines on which Zookeeper is running parallelly. This is a cluster. Okay, one of them is marked as leader, rest are followers. Okay, now this is the folder structure you can see in the this is the what do you say, status of the zookeeper. You can look at the zookeeper hierarchy. Okay, all right. So generally you can see the zookeeper hierarchy here. Okay, okay, let me make a note of this one as well. So all right, those who want to try HBase now, it's working fine. We had to restart it, so our team has restarted it. If you want to try now, you can try the HBase REST interface. Right? Let me take a look into it because we had tested it already and it was working perfectly fine. Okay, never mind. So yeah, so generally you can see the zookeeper from here. No worries. Now let's move on to the next point. All right. Now let me talk about the architect. This is very, very important. So everybody should pay attention to it. This is going to be because it uses a strategy called Paxos algorithm. Okay. So the design of Uzi is based on Paxos algorithm. And if you read the paper, it's actually quite unnecessarily complex. I'll try to make it very, very simple. If you have a question, just let me know. Okay, it's if you are interested in politics, you will definitely enjoy it, and even people with a little it's basically a very interesting way to look at how systems talk to each other. Okay, it's quite an interesting thing. Okay, so and even if you like the the Indian the Sas Bahu kind of serials, then also you will like the Paxos algorithm. All right, and let me start with it. Okay, all right. So basically, the design of Zookeeper has two modes. One is called standalone, which is just for testing, and it has no high availability. It's not that interesting. That's just for those people who are running virtual machines of any of this would be using Zookeeper in that mode. Okay, but the real thing about Zookeeper is the replicated mode. So in in replicated mode, Zookeeper runs on a cluster of machines and we call it ensemble. We give it a nice name called ensemble, this cluster of machines. Cluster of machines is it? Many computers connected over a network, okay? Over a Wi-Fi or whatever you want to use. All right. Now in this, it's quite highly available. Okay, we'll show you how it's highly available, and it keeps on running happily as long as majority of the computers are up. Majority means more than half. More than half. Majority, in case there are three computers, majority means two. Okay, in case of two computers, majority means two. In case of one computer, majority is one. In case of 20 computers, majority is 11. Okay, so this ensemble will happily run as long as there is majority of the computers are available. All right, now the architecture. So initially, what you do is you install zookeeper servers on every machine in your cluster. Okay, so all these machines, let's say here there are three machines, A, B, and C. All these three machines are running the zookeeper server as in there's a program called server which runs on 2181 port as you saw just now, and all these three machines are running parallelly and talking to each other. They know about, all these three machines know about every other server running the zookeeper. Okay, so we turn them on, we switch them on, and then what happens is something interesting. They start talking to each other, and the first thing they do is, first thing as we start these machines, we basically configured the server, and then we started the zookeeper servers on all these three machines. And what magically starts happening is they all start communicating to each other. And the first thing they do is, all of them, first thing they do is do the leader selection. They gossip amongst themselves to select a leader. And basically, whosoever is more responsible. So every machine makes the opinion about other machines based on number of pings responded by the other machines, and then they reconcile the nodes. All machines reconcile the nodes, and then the machine who is designated as the leader wins and becomes the leader, and become the rest become the follower. Okay, now what is the significance of other of being the leader? The leader, all the nodes who want to change something, like we wanted to create a node, they will be redirected to the leader. Okay, followers will only be used when we say get me the list of children, or give me the data node, give me a z node data. So for every read request, followers will be used, while all the write requests, the requests that involve change, would be forwarded to the leader. Okay, so as soon as the network is up, the nodes are talking to each other, voting about each other, gossiping amongst each other, and the election happens, and the somebody becomes the leader. And the moment somebody becomes the leader, rest of the followers synchronize their state with the leader. Okay, if the leader fails at any point of time, somebody else will become the leader based on the election. So as soon as a leader fails or leader steps down, election happens and somebody else becomes the leader, and then the same process keeps on happening automatically, and the election takes around 200 milliseconds. If the majority is not available at any point of time, the leader will step down. Okay, if so, in this democracy, if lesser than 50% votes, if lesser than 50% people, 50% or or lesser people voted, then election is invalid. There is no leader. The whole system will remain read only. There will be no change that can happen in this system. So majority is not available at any point of time. The leader himself, even if there is a leader, he will step down. Okay, now once the election is successful and leader has been elected, what happens? Every write request is forwarded to the leader. Leader broadcasts the update to the followers. When the majority have saved or persisted that change, so when we said create node, that change went to majority, went to all the nodes. Okay, which means the most important thing you need to understand, not most, one of the very important thing, that the data on every node is same. Okay, any change you make is propagated to the whole cluster. That means you should always store small data you should always store small data on zookeeper cluster. So when majority saves the change, only then the leader says commits, and then client gets a response that your change were successfully written. Okay, majority is again the keyword here, meaning in case of five node, when if I have five nodes in the cluster, three is the majority, and unless three nodes successfully write the change, I would not get the response. But luckily, since all the three writes are happening in parallel, so it does not take much time. The protocol for achieving the consensus is atomic, like two-phase commit. Okay, so when we are basically reaching to a consensus, like I mean, when we are writing the data, it's basically a commit. Now, most other important aspect about Zookeeper is that it saves the data to the disk before the memory. All right. Uh, Let me check if you have a question for me. So Prabhu's question is, how many Zookeeper leader can we have in a cluster? Only one. We cannot have more than one leader in the cluster. Okay. Parvez's question is, there is no server capturing amongst servers. So yeah. So actually, I mean that's a very good point. So Paxos has two variation of the algorithm. One is where they trust each other. Other, there is no trust amongst the people who are voting. And the algorithm is two very different in both the cases. All right. Question from okay. So all right. Sukhvinder is saying that we should tell this story to the people who are not following the leader. Okay. And Prabhu is saying, is this type of zoo configuration part of Hadoop developer role? Yes, we should know this. This is a very important aspect because any big data developer is supposed to know this Paxos algorithm because uh, people might ask you these kind of voting things, and it actually takes a bit of time to think. If you think about the fact that the logic on every zookeeper server is exactly identical, then how do they reach consensus? How do they elect things? It's actually very interesting. If you think of it and if you try to design it, then you will realize that having election when every node is exactly identical is very difficult. Which one reconciles, which one doesn't reconcile, how do which one compares with who, and so on. There'll be these questions. Okay, because we have not lived in a exactly symmetric society, therefore we don't face those kind of scenarios. All right, Satyan, you will understand that part now. A question from Vivek. So if a follower fails, the leader has to, if the majority is violated. That's right. Good question, Vivek. I was hoping that somebody will ask this question. Uh, Question from Parvez is, uh, question from Sukhvinder is, okay, yeah, all right, and yes, okay. So yes, Parvez. So I'm trying my best to explain it in very simple words. Okay, so I'll be skipping a lot of fine details which are generally not required. Okay, so question from Muhammad is, what are the motives behind Zookeeper? Which other technologies use it? Probably every other system uses Zookeeper. Okay, be it I mean, even components outside Hadoop, they use it right now HDFS, MapReduce, and HBase, all of them uses Zookeeper, along with things like Storm, Kafka, and there were few more when we did LS. Lots of people use Zookeeper. Okay, all right. So I'm not yet talking about that diagram, Sneha. No worries. Okay, a question from Vijay. Acha, okay, so I have answered actually second part of Mohammed, but not the first part. Okay, okay, good, very good set of questions. Let me answer one by one. All right. So the other motives behind Zookeeper is any system that requires coordination need Zookeeper. So if you are running a distributed program, you will end up with a lot of coordination. Now having a coordination is a tough game, and instead of you creating your own service so that they can coordinate with each other, you can use Zookeeper, which provides you all the constructs that are needed for synchronization and coordination and keeping the configuration values. All right. So, Isneha, which diagram are you talking about? The election one? You want me to explain the election again? I think she's not able to hear anything. Okay. So, okay. So now the question to Vijay's answer to Vijay's question. So, on what basis is the leader chosen? So, there are a couple of criteria. One, who has latest data? Okay. As I told you that every node has got a number, a Z node counter. Okay, which tells that which keeps so basically the data Zookeeper tracks the version number of the overall data. So whichever node contains the latest data is the default candidate for becoming the leader. Okay. Second, if all of the node have equal state of the data, then the time taken to respond to pings. Okay. So there are these few criterias to choose a leader. Now, there's a question from Prashant. On what basis would a follower fail to follow? Generally, if a follower is dead, okay, it could be network issues or machine issues, okay, or it could be software or the services issues, firewall, this, that. There could be many more reasons for not following. So Prabhu's question is leader technically a data node on which Zookeeper client is installed? So I would just make a modification. A leader is technically a node on which Zookeeper server is installed. So maybe in your cluster you do not install data node on all machines. Okay, for some machines you will install Zookeeper, on some machines you will install data node, on some machines you will install region servers. So it is a choice that you make. Okay. So Sukhvinder's question is, when Zookeeper came in big data, who are the providers of Zookeeper? Zookeeper is open source. Again, it came along with HBase, and it's based on the, again, it's inspired by the Google's paper, and it there was something called chubby service, okay, in Google's paper, and based on chubby service it has been written. A question from Parvez is there any nomination by the leader as a deputy leader in case leader's machine is down? No, because it again opens for the election. Yes, yes. Okay. So in this environment, we are trusting each other node. Yes. All right. Good. Now back to the architecture. So there were ensemble as in there were bunch of machines. We started on every machine. We started Zookeeper server. So Zookeeper service is nothing but a process listening on a port and talking to other machines. Okay, every machine knows who are the Zookeeper servers available in the network. So Zookeeper servers talk to each other, elected a leader based on who has the latest data and who responded to the pings really, really well. And then they choose a leader and they synchronize their state with the leader, and then the story starts. And all the right requests, whenever there is a change, delete or update or get or set, the request goes to the leader, while read requests can be served by anybody. All right. So this is a simple architecture. Now, question to all of you: if you have three nodes, A, B, and C, A being the leader and A dies. A being the leader and A dies, as in A get disconnected from the network. Will somebody become the leader? Quickly. So question is, if you have three nodes A, B, and C, will somebody become a leader if A is no longer available? Yes, that's right, because 2 is still a majority. Okay, so as soon as A is dead, automatically the machines will talk amongst each other, somebody will become the leader. Okay, now either B or C, based on the circumstances, will become the leader. Now, question is, what happens when B dies? Let's say C got elected as a leader, and after a while B is also dead. Only C, who is the leader, is left. Will C step down from being the leader or will remain the leader? Anybody? Very good, Thiru. Okay, so okay, let me explain again. So when A was dead, two nodes were left. Two out of three is still a majority. 3 divided by 2 is 1.5 and 2 is greater than 1.5. Therefore 2 is a majority. Therefore re-election happened. Now what happened was only one node is left. So the leader will step down. Leader will step down because he's the only one left, or there is no majority in this system. Okay, so we will this is something which took me a while to figure out why is it so. At in the first I thought that okay, at least there is one computer available, let's not it should have kept on running and serving the request. But C steps down from being the leader and becomes the follower, and so no one becomes the leader. C will become the follower. Okay. Since majority is not available, A is lesser than 1.5, which means lesser than 50% of 3. Therefore, there is no leader. Even if there is a leader in these circumstances, he will step down. Okay. So any ideas? Can somebody give me any ideas why this kind of a weird rule that at least I have some computers left, let it run? Why would it step down? Anybody? Yes. Basically, as soon as there is no leader, what happens is there is no write request being served. The whole cluster, the whole zookeeper becomes read only. So any ideas why C has why such kind of behavior? Why do we need majority? Satyan is saying that no distribution of services so that we do not lose info if the last one dies. Okay. Vijay says replication issues. Okay. Parvez says configuration will not happen. Okay. So only read only operation. Okay. Mohammed is saying that maybe some fatal error is occurring in the cluster. Okay. Parvez says that basic property of zookeeper will not be utilized. All right. All right. Let me check Prashant's answer also, so that it remains reliable. Good. Good. Very good point. Okay. So, all right. Uh, Let me go to another. Yeah. Now let's come to the actual answer. I think you will appreciate this part. Let's imagine that there is this data center, there is this network where you have data center 1, data center 2, having total number of 6 nodes, and A being the leader. A is the leader while others are follower. Please note that out of 6 nodes, if 3 nodes are dead, the leader will step down. Even if there are 3 nodes available, it will step down because I mean, let's understand the reasoning behind it. Let's look at this. There are two data center connected by a wire. One data center containing A, B, and C, and other data center containing D, E, and F. Now A is the leader, and we have all of them are happy. B, C, D, E, F are all followers and serving all the read requests while the changes are being forwarded to A. Any change comes to D, it's forwarded to A, and so on. So everybody is forwarding the write request to A, and they are serving happily the read request. Now, something strange happens here in the network, and the connectivity between data center 1 and data center 2 is dead. So, now on one island there is A, B, and C, and on another there is D, E, and F, right? In these circumstances, what goes on is now imagine that majority kind of rule was not there. Let's say zookeeper did not follow majority kind of a rule and elected whosoever gets maximum votes. What could have happened is both the islands would choose their own leaders and will start accepting write request. Any write request is coming to say F is being forwarded to D. So let's imagine that this could have happened. It could have been disastrous. The cable got disconnected between the networks. The data center 1 had chosen its leader called A, and data center 2 had chosen the another leader called D. Had majority rule was not there in the architecture, this could have happened. And what would that lead to? Two leaders in the same country, everyone running the system their own way. And why does it become disastrous when it comes to the information? Imagine that the same tree of information having two separate variation. In one there are some more nodes getting added, other in another some other deletions are happening. It could have been beyond reconciliation. It would become beyond reconciliation. You won't be able to reconcile. Okay, so the data could have been equivalent to getting corrupted if the majority was not there. Okay, now if that happens in reality, what happens is that the leader A noting down that okay, only the vote of B and C is available to us, meaning only the three nodes are available right now. Only the three nodes are available right now. So leader A would step down, and in the data center 2, nobody will be the leader. Make sense to you? Everybody convinced? Okay. Prashant's point is that if it fails, there is not other application available. Yes, that's also a good point. Prabhu's question is on data nodes, can there be any other clients? Yes, of course. Okay, so data node is not a machine. Data node is just a service running, a process running in the background, and everything we have talked since the beginning till now, everything is just a process listening on a port. Okay, all right. So basically here, all right, let me repeat again quickly. So basically, if there is this kind of scenario, if you and there was no majority kind of a rule. Majority rule says that for election there should be at least 50% people available, for more than 50% people should be available to vote. In this kind of scenario, when the network got disconnected, here there is a three people available to vote, and the other side also there are three people available to vote. In case there was no majority rule, both the data center will choose their leaders and both the leaders will start operating at the same time, taking the right request, which means the consistency of the data is completely lost. Two leaders means two write requests parallelly being served by two different nodes changes are happening to the same thing parallelly by two different nodes, and the whole integrity of the system is gone for a toss. All right. Therefore, it is to ensure that there is always one single leader. To ensure that there is always one single leader, there is a rule of majority. No partitioning of the network. This is called partitioning of the network. No partitioning of the network should impact. No partitioning of the network should cause multiple leaders. Therefore, it is because there can be only one majority in any kind of a topology. It's like saying that it's my birthday and I should get the biggest cake. It's my birthday, I should get the biggest cake. And how can I make sure that I get the biggest cake? By saying that I should get little more than 50%. Similarly, to ensure that there is only one leader, there is only one such network, it is made sure that leader says I need more than 50% majority, and that can be only one, not more than, there cannot be more than one 50% majority in any network topology. Okay, a question from Parvez. If we have three nodes having one lead, okay, one leader and three followers, two followers. If any of the followers is down and is replaced by more updated machine, can the reflection happen as a powerful machine? Is re-election happen if the powerful machine is introduced in the cluster? Okay, so re-election does not happen unless there is a tragedy. Tragedy as in leader could not respond on time, or leader is dead, or majority is no longer there. Only then the re-election happens. Because for re-election to happen, there is a 200 milliseconds period. Okay, so that way. And also when you're adding more powerful machine in the network, you will have to inform all the servers. Okay, so election is not, election is not going to be contested unless there is some serious requirement. Okay, a quick question to all of you. In an ensemble of 10 nodes, okay, an ensemble of 10 nodes can tolerate a shutdown of how many nodes? Anybody? Good. That's right, Satyan. Read the question again, Prashant and others. Yeah. Athiru. That's right. Good. Good, Asmeet. Good, Sukhvinder. Good, Leela. Good, Mohammed and Thiru and Suraj. Good. So it can only tolerate the shutdown of less than 50, not half. Okay? So the answer is 4. Good? Alright, there's some more details I need to provide you. So, uh, Zookeeper provides you an idea of sessions, just like you have web sessions or TCP/IP sessions. Similarly, Zookeeper also provide you sessions. A client, the client which you use for connecting to Zookeeper servers, has the list of servers in the available, which means the client maintains all the list of IP addresses. It will keep on connecting to each until it's successful. And then it creates a new session. On the server side as well, a new session is created for the client. Okay, and every session has got time period, decided by the caller, as in the client. Okay, just like any other web server. Okay, if the server has not received a request within the time period, it might expire the session. If the session get expired, ephemeral nodes are lost. Okay, so to keep the sessions alive, the client keeps on sending the pings, or called heartbeats. Okay, it's like you keep on refreshing a web page so that it doesn't time out. Okay, similarly the client keep on doing that, but good news is that your program doesn't have to do it. The client library underneath which you're going to do will take care of all the heartbeats. Also, this client library handles the failovers, and sessions are valid on switching to another server. Application can't remain agnostic to the server connection, because while your software, your application is trying to create a node, maybe there is a real action happening. Okay, so you have to be aware that the connection might fail. Okay, so this is a simple connection, as in you create a connection, it's connecting, and then it gets connected, you get an update, and then the connection gets closed. Now, one of the big use case of Zookeeper is if you have millions of clients connected to Zookeeper or to a web server. So on the back end, you have a load balance service. Load balance service means a service being run on many machines parallelly, and and there are thousands of clients who would use this service parallelly. Okay, now how to discover which server is up, which server is down? Okay, one way was that all the clients are maintaining a list of servers and keep on pinging to every server and checking which server is up. The right way is to use Zookeeper as the coordinator in the middle. Okay, so every server will create their ephemeral nodes, so that their ephemeral nodes will be up as long as the server is up. In case server goes down, their ephemeral node will disappear, and the client will not talk to them. Okay, on one end all the servers will create their ephemeral nodes, and on the other hand the clients will talk to the Zookeeper and get the list of all the ephemeral nodes, and will try to connect to only those which are active right now. Okay, so this is, let's say there is a server which connected to Zookeeper and said, hey, create my connection, and then it creates a Z node called duck under servers. Then another server comes up, says create a Z node, ephemeral Z node called cow under servers. And at this point of time, if somebody comes, as in a client comes and says, give me the list of available servers, Zookeeper will say it's duck and cow. But after a point of time, if duck server gets killed, this duck server get killed, so this ephemeral node will disappear. And if that disappears, the Z node will disappear, and which means the list ls/server will only return cow, not the duck. Okay, so this is how the coordination between the discovery of the client server from the client would happen. Okay, so it guarantees that there will be a sequential consistency. Update from any particular client are applied in the order, like the way we were talked about eventual consistency. Here there is a sequential consistency because every change has got a number on it. Atomicity, either Z node change fails or successful. There is no midway. There's a single system image. A client will see the single system image. Okay. The new server will not accept any connection until it has caught up. Okay. So as we told that it provides durability, as in if a change is a change, it is not lost, it is not in the memory, it is in the disk. Timeliness, rather than allowing a client to see very stale data, a server will automatically shut down. Okay, this is a very important part. A server will kind of commit a suicide if it is stale for quite some time. All right. Now there are various kinds of operations which we have already seen: create, delete, exist, get CL, and get ACL, as in access control list. Access control list is something very not too critical for us. Basically, when you have many programs in the network, they might want to access. So we might want to control who is modifying. uh, so if you have many clients, you want to secure one Z node from another, and that's when the access control lists come into play. All right. Now the update could be multiple or single. Okay. So this is the API for Zookeeper is quite strong. It provides it provides you a way to combine multiple operation into single, just like database transactions. In a database transaction, you can say add a row, update a row, delete a row in a single transaction. All of the changes will happen in a single shot. In the similar way, multi-update makes sure that all the changes, like creating a Z node, deleting something else, creating 10 Z nodes, all of this would happen in a single shot. There will be no midway state. All right. So the API which Zookeeper provides you are of two kinds, which is one in Java, other in C. The contributed ones are for Python and REST. So the interesting part is that there are two versions of every function. One synchronous, other asynchronous. What does it mean by synchronous and asynchronous? Okay, anybody? What is the difference between synchronous and asynchronous? Yes. A synchronous function and asynchronous function. What's the difference? Anybody? Satya says if the calls are synchronized, meaning second operation does not start until the first one has finished. While asynchronous will execute parallelly, brilliant Satyan and Sukhvinder and Vivek. Sukhvinder, I think your answer is for different kind of system. Here we are talking about synchronous call. Okay. All right. So there are two ways to talk, two ways to communicate. Okay. Let's say you make a call to me and start discussing things. Okay. Saying, okay, so how should I say? Um, let's say you want to check that the session has been started or not. Okay. Or how should I say? Let's think about the hotel reception. Okay. So hotel, there is a hotel reception. You are staying in a hotel, and you are expecting a visitor. There is one way that you keep on calling the reception again and again and asking them that, has my visitor come in? Has a person called Sandeep Giri come in to visit me? Or the hotel receptionist says to you that, hey, I will call you back when somebody named Sandeep Giri comes in. Okay. So in one case, you continuously pinging. Okay. And in another case, you have just told them they'll call you back. Okay. So in one way, you can say that, or you called the receptionist and said, Stay on the phone until Sandeep Giri comes in." That is synchronous call. You are waiting until the work is finished. Okay. In other way, asynchronous, your call finishes quickly and you get a call back when the real event happens. Okay. Every publisher subscriber model is in the same way. Okay. A question from Suraj: what does it mean by the core APIs are written in Java and C, while Perl, Python, REST is contributed by people like you and me. All right. Now, so there are these APIs which provide you the callback, and you can also, there's something called watches. So sometimes you want to get notified saying when something happens, just inform me. Like we had triggers and post processors and pre-processors in HBase. So here you want to say that you want to get registered, you want to get watches when something happens on the Z nodes. Okay. So watchers are triggered only once, just like in JavaScript. So you will have to uh, basically re-register every time. Okay, you cannot keep getting the updates. You will get only update once, and then in that update logic you can resubscribe. Okay, so when does watch trigger? The watches that are created in the function called exist are triggered when the nodes are created, deleted, or updated. Okay, or get data, the watches of get data gets triggered when a Z node is deleted or its data get updated. The watches, because the watches are configured when you call a function called get, like exist, get data, or get children. So the watches of get children get invoked or get executed or get called when a node is deleted or any of its children get modified. Okay, so those are called watches. The other thing is ACL, access control list. You can have the permission like authentication and authorization. Okay, the authentication could be based on login password, or it could be based on something called Kerberos, or it could be based on the IP address. All right. So access control list is a function of what kind of authentication you are using, the identity of this of that scheme, and the set of permissions. All right, we have gone through hands-on. We've already tried all of this. You can try by yourself. All right. So the other use cases for Zookeeper are building a reliable configuration service. Okay. Another is building a distributed log service such that not too many process can talk to the same. uh, I mean, not two process have the race conditions. Okay. All right. Now, when not to use Zookeeper, that's a very important part. Do not store big data inside Zookeeper. The total number of copies are equal to the total number of nodes. So, and also all of the data that you store in Znode will be loaded in the RAM. So Zookeeper is blazingly fast. Zookeeper is extremely reliable, and Zookeeper is sequentially consistent, or you can say heavily consistent. Okay, but the downside is that it keeps data in the RAM and it keeps many copies of the data. So if you are trying to store a 1 gigabyte data and you have 10 number of nodes, it's going to consume overall 10 gigabyte of data and 1 gigabyte of RAM on every machine. Okay, so also it provides you sequential consistency, not strong consistency. Although here the consistency is going to be great, but it's not as compared to using a singular system like a database or like a file system. So it's not extremely strong consistency. It's basically what do you call, sequential consistency. All right. So that was Zookeeper. Any questions related to Zookeeper? Yes. All right. A question from Parvez. Can we say Zookeeper is one type of advanced network load balancer? You can use it like a network load balancer, but uh, yeah, you can definitely use it like a load balancer, but it's not like a traditional load balancer. It's not like a typical load balancer. All right. So it's more like a file system which runs on many machines, but this file system can only be used to store small data. All right. Although it looks like, from whatever discussion we had, it's a great system, but it has got its own limitations. Okay. So Satyan has an answer to you. It's not a load balancer at all because all writes are done by the leader. Good. Good point, Satyan. Thank you. Because in load balancer, you have a single system centrally, which is routing the customer's request to multiple machines. And in load balancer, every machine, it can read and write. All right. Now let's talk about Scoop. All right. Let's talk about Scoop in the next session. Okay. So we'll have two more sessions. Okay. I hope that it finishes in two more sessions. If not, we can have one more extra class. All right. All right. Prabhu, I don't have the docs for Storm Accumulo, but yeah. But Kafka, we will have the discussion. I can share a video from my Spark class where we are having the streaming demo. Okay. Because I would like to keep it. I would like to explain to you the use case of the streaming session in my. Okay. All right. So yes, I'll share the video from Spark class for the Kafka demo. Okay. All right. Good, Parvez, that you got it. So next week we are covering, next weekend, we have Hive and Spark along with smaller tools, okay, like Scoop and Flume, that will be like quick. A question from Sukhwinder: where can we get commands for NoSQL? NoSQL is not a database, it's just an idea, it's a class of databases. Okay, so if you need exactly what commands are available for HBase, you can just start HBase shell and see all the commands. Yes, we will discuss the Hive next week. All right. So that was our discussion on Spark and HBase today. Okay. So Vivek's question is, what type of project work? We're planning for sentiment analysis. Okay. If you finish that, we will work on something more. Some more work has come in. Spark will be next week, Sukhvinder. Okay. Is that your question? Okay. All right. Parvez is saying that I'm not able to practice much on Pig. Can I have? Yes, yes. You can go ahead and download the virtual machine the way we have explained in first session. Read, check the if you want to install it locally, you can go to this one and install on it, go through the installation instruction. Okay. Leela is saying this class seems basic. Do you have in-depth class for each MapReduce and yeah. All right. So for MapReduce, I was assuming that it is in-depth. All right. So okay. All right. Yes, Sukhvinder, I was planning to have the discussion, but then I realized that in 1.5 hours, I could not have completed Spark. That's why I thought I moved ahead. Okay. Let me take a look at again. All right. Ashok. No problems. Okay. No problems, Prabhu. All right. So have a great week ahead and finish your past assignment and submit those. All right. Bye bye. Have a good day. I missed your questions. Okay. All right, Prashant. Good. Okay. Good, Parvez and Leela, that you like the sessions. All right. Bye bye. Have a good week ahead.